Hello everybody, so we are dealing with a problem from 2022 JEE Advanced and the problem is based on the concept of projectile motion. So let's get started with the problem. The problem is stating a projectile is fired from horizontal ground with a speed v and projection angle theta. When the acceleration due to gravity is g, the range of the projectile is d. If at the highest point in its trajectory, the projectile enters a different region where the effective acceleration due to gravity becomes g by 0.81 and the new range is d dash, which is equal to n times d, we need to determine the value of n. So if you want to give this problem a try for yourself, you can pause the video and start solving it on your own, or you can continue watching. So we will start by drawing the diagrammatic situation and we will write the results which we know for projectile motion. So this is the usual case of projectile motion which we have on the left hand side. So over here we say that the range of the projectile is equal to v square sine 2 theta by g, or we can write it as 2 times sine theta cos theta by g, and this value is referred over here as d. So in the problem it is stating that when the projectile is fired in these cases, the range of projectile is d. So in the problem this is referred as d. Now in the next part it is stating if at the highest point in its trajectory. So if I talk about the highest point of the trajectory, then at the highest point of trajectory the final velocity in the y direction is 0. Now since in the case of ground to ground projectile there is no acceleration in the x direction, so we say that the velocity in the x direction is always constant, that is the component v cos theta is not changing throughout the projectile path. So at the highest point also the component along x of velocity is going to remain v cos theta. Now it is also attaining a height as it is travelling the projectile path. So h maximum can be written as v square sine square theta by 2g. So over here we can say that this is the case which will become once it enters the region of different acceleration due to gravity. So at this point when the velocity is v cos theta and height is h max, which is v square sine square theta by 2g, so it enters a different region where the effective acceleration due to gravity becomes g dash, which is equal to g upon 0.81. So now if we write a standard result for this part, then we can say that the range r naught is equal to u times the total time of flight, and the total time of flight is equal to root over 2h by g. So over here in this case r naught is equal to, so this term u is going to become v cos theta, then we have root over 2h, so 2. The term for h will be v square sine square theta by 2g, and then we have the value of acceleration due to gravity which is in this region. So this value is equal to g upon 0.81. So this is the expression for the range r naught which we have. If we solve this r naught, then we can say r naught is equal to, so 2 and 2 cancelled out, v square will come out, it will become v square sine theta cos theta, g square will turn out to become g, and then root under 0.81, so it will become 0.9. So this is the expression for r naught that we have. So the total range over here in the problem is stated will become d dash. So d dash can be written as, so it will be half the range value, or d by 2, and then followed with d by 2 it is this value. So this is d by 2 into 0.9, so 0.9 times of d by 2, where the term d is equal to 2v square sine theta cos theta by g. So v square sine theta cos theta by g can be written as d by 2. So d by 2 times 0.9, and on solving over here we obtain a value that it is becoming 1 plus 0.9 is becoming 1.9 by 2d, and it is equal to 0.95 times of d. So over here in the problem it is stating that the range becomes d dash equal to n times d. So the term n over here is equal to 0.95. So for this problem n is equal to 0.95. So this is the answer for this particular problem, where we have dealt with the basic concepts of ground to ground projectile and horizontal projectile.